Summertime, I got lots of flexibility most of the time. So.
Okay, perfect. Well, today we're going to be doing systems of equations.
Okay.
So this problem is 2x plus 9y
Hold on.
equals -8. Okay.
Yeah, sorry, I got to turn this on.
No
2x,
problem.
what was it again?
Plus 9y equals -8. And then underneath it is 3x minus 4y equals 23. And I have to solve for x and y.
All right. Call that equation number 1. Call that equation number 2.
Okay.
You have two methods for solving. What are they?
We'll make a multiply.
Substitution and what else?
Would I distribute a number?
Elimination. This is called elimination. In other words, the very first thing you have to decide is which method are you going to use? Are you going to use substitution or are you going to use elimination? Now, when both equations are in standard format, I'm pretty convinced that elimination is almost always easy.
Mm-hmm.
These are in standard format. In other words, the x's and the y's are on the left side of the equation, the number is on the right side. So that's the first decision. We're going to solve it by elimination. Now, how can I eliminate a variable? I'm allowed to add equations or subtract equations, but nothing goes away.
Okay, yeah, that's true. So I have to bring them both to the same.
I'm also allowed to multiply any equation by the same number on both sides.
So I can multiply the top one by 3 and the bottom by 2.
By 2. Okay. So the top one, let me make a suggestion. Instead of multiplying the top one by 3 and the bottom one by 2, let's do the top one by 3 and the bottom one by -2.
Okay.
You'll see why. So if I do the top one by 3, what do I get?
So it's going to be 3x plus...
Nope.
I mean 6x, 6x plus 27y equals -24.
And the bottom one I'm doing by -2 because I want to be able to add these two equations when I'm done.
So it'll be -6x plus 12y. Plus 8y, 2, and -46. So then after that's all said and done.
The biggest reason is people don't have trouble with adding. They have problems with subtracting. So when you're setting up your two equations to eliminate a variable, try to set it up where you can add the two equations. All I'm doing is adding 1 to 2. What do you get?
Okay, so it would be 0x plus 35y equals 70, -70. And the y equals -2.
Now, how do you solve for x?
So I can just put substitute -2 in for y on the top equation.
Yeah, on whatever is the easiest equation. Even though I ran a line through them, I really shouldn't have done that because you generally want to go back to the simplest equation, which is going to be the original 1 or 2. So let's use, you said 1?
Yes.
So we got 2x plus 9 times -2 is -18.
18.
Equals minus
-8.
8. The only thing you have to be careful about using that original equation is that you don't use those. In other words, that you use the exact original equation. Okay? And this gives you 2x is equal to 10, x equal 5.
That's 5.
Those are your two solutions. And that, I think, is the absolute simplest way to solve that.
Okay.
You do have an option to solve them by substitution, but to solve them by substitution, you would have to solve one of these equations for either x or y, have a very complicated expression, and then substitute it back in and have to handle all that tough arithmetic. So elimination turns out being quite simple compared to the alternative.
Makes sense.
Okay. What else?
Okay, so the next one is negative 4x minus 7y equals 24. And then I have negative 2x plus 5y equals 12.
Which method are we going to use? Substitution?
Elimination.
Okay. What's the
So I'm just going to multiply the bottom by 2.
But if we multiply it by negative 2.
Okay, negative 2.
You see why?
So it'll be easier.
Well, it turns out giving you a plus 4x. And that's what you want, is to be able to add your two final equations together.
Yeah, that makes sense because they won't build them.
Yeah, in other words, you don't want to have to subtract. You can. It's just as legal to subtract equations as it is add them. It's just that it gives a lot of people more problems. So I usually try to encourage people to set it up so that you're going to end up adding, not subtracting. Now, I'm going to run a line through that. We don't ever need that equation again. So now deal with 1 and 2.
So negative 17y equals 0. So y equals 0.
Okay, now what?
So now I'm going to put the 0 into the second equation for y.
Well, okay. You could put it into either equation.
Yeah.
The only reason I would put it into the first equation is because I've manipulated the second equation. In other words, I could make a mistake if I try substituting 0 for y. I might include that minus 2 or that minus 2 by mistake. So let's just put it into the first equation. There's nothing going on there.
So negative 4x and 0 equals 24. So it'll just be negative 4x equals 24, and it'll be negative 6.
There you go. See how simple that was, and there was no chance of a mistake.
True.
All
right. Okay, I've got one more of these. And it's 2x minus 3y equals negative 9. And then negative 7x plus 2y equals 23.
What are we going to do here?
So for this, I'm going to solve for y through elimination. And I'll multiply the top by 2, and I'll multiply the bottom by negative 3.
Yeah, what that's actually going to solve for is x. And you don't need to multiply the bottom by negative 3. You need to multiply the top by 2 and the bottom by 3. Notice that that will give you, here's my new, I multiply the top by 2.
Yes, I see now.
Okay.
Could keep it negative, and then I have to keep the bottom positive.
You want to have one negative and one positive. Then when you add them together, they disappear. So there's equation 1. Equation 2, I'm just going to multiply by a positive 3. That gives me minus 21x plus 6y.
6y.
That's what you're looking for.
And 69.
It will cancel. Now add everything together. That's weird. Did we make a mistake?
That is weird.
Well, it's going to be weird because now we're going to have a weird fraction and they're going to make it harder to solve for y. I don't see the mistake though. Was minus 2x to begin with, or was it 2x to begin with?
It was 2x normal.
That's
so
a
just be 4x.
There, which means that's a 17, which means x equals minus 3.
Okay.
Notice that when I got an answer that I wasn't expecting, it was a flag that I've made a mistake. I got to go back and check my math. My problem is that I read that as a minus 2x, when this little symbol right here was just the 2 that I was multiplying by.
Mm-hmm.
So I got a strange answer that I didn't expect. Go back, check it. Now I figured out the correct answer. How do I solve for y?
So I'm just going to put in the negative 3x for the top equation. So it would be negative 6x minus 3y equals negative 9.
Hold on, Taylor. What you're doing
Yes.
is substituting negative 3 for x.
Oops, I mean not x. Negative 6, I mean minus 3y equals negative 9.
Okay. And then if you do the rest of that, you get
1, I believe.
Uh-huh.
Since 6, negative 6x minus 3y.
Now, if your life depended on it, you'd probably take these two answers and substitute it into at least one of the original equations to make sure that it was correct. Notice that if I substitute minus 3 into the second equation, I get 21 plus 2 equals 23. That's correct. I'll risk my life on that being the correct answer.
Okay.
No, I'd have to do it to both equations to risk my life. I've never seen it where it works for one and not both. But if I was really risking my life, I would plug it into both and make sure it worked for both.
Okay. So the next one I have is graphing an inequality.
Okay.
So it's y is greater than negative 3x plus 5.
First thing you really want to do with these is graph the equality. It's a straight line. How do I graph this?
That would be.
Where do I start?
So I would start at the origin. However, then I would move up 5.
Start at the y-intercept. That's the y-intercept, plus 5.
Okay, so plus 5.
Apply the slope. What's that slope mean?
Negative 3 over 1. So rise negative 3 and then run 1.
Okay, I'll go up negative 3. I'll go up 3. 8. Now what?
And then go to the right one.
What kind of slope would that give you? Positive or negative?
That would be a positive slope, but this is a negative one. So we'd go left one.
Left one. Now
Okay.
I'm connecting these 2 points. I'm connecting that point with that point. That's going to give me my straight line. But normally it would be a straight line if I was graphing this, but I'm not graphing that. I'm graphing this inequality. So I have to answer, is it a solid line or a dotted line?
It's dotted because it's not greater than or equal to.
Correct. That's the difference. So once you figure out 2 points on the line, then you have to figure out whether it's dotted or straight. Now, which side of that line am I on? And I want your answer to always be over or under, not right or left.
Okay.
Is it over or under that line?
How do I determine that?
Right there, what
The greater than it, so it'd be over.
Exactly. In other words, you always look to the y-axis. So all you want to do is find a point on the y-axis that is above that line. Any point will do. And what that means is this is the side that is shaded. Now,
Okay.
even though that looks like it's to the right, that's not the way you want to think about it. You always, because almost always these things are given to you with y on one side, then the inequality sign, and then a linear expression on the other side. So it's always you're looking to the y-axis. Not looking, your eyes are not looking left and right. They're looking up and down because it's the y-axis.
Gotcha. Okay. So the next one I have is y is less than 5x minus 1.
2 points on the line.
So I'm going to start off at -1, or y on the y-intercept of -1. And then I'm going to go up to 4 and move to the right 1.
There's my 2 points on the line.
It'll be dotted. It'll be a dashed line.
That's what I meant, dashed or solid. And which side of that?
It's going to be below.
Okay.
So it's going to appear on the right side.
Yeah, although I don't even
Now
like.
I see what you mean. It would have been wrong if I picked left.
I don't like to mention it because it confuses people. In other words,
Yeah, that is
always
confusing.
looking to the y-axis. There is only one exception. Let me give it to you.
Yeah, that is confusing.
Yeah. If I said this, that is the only time you're going to call out an answer that is right or left, because there is no up or down here. Am I to the right of that or to the left of it?
So you're going to be to the right, I would assume?
Yeah, it's x greater than.
Yeah, it's
In other words,
right
in
of
this
it.
case, you're looking at the x-axis. But this is very rare. The only time you ever see anything like that is when you have a vertical line. When you have a vertical line, there is no up or down. There's no y. But if you have a y and it's on the one side of that inequality sign and everything else is on the other, then you're only talking up and down. You're never talking right or left.
Okay.
Okay, what else?
The next one is graph the inequality in the coordinate plane. So it's x is less than -3.
That's funny. That would have been funnier if it was x less than 3.
Mm-hmm.
What kind of line am I looking at?
So it's going to be a horizontal line.
No.
Oh, it's going to be vertical because it's on x.
And it goes through what point on the x-axis?
-3.
Yeah. Exactly what I just drew, accidentally, only I went through +3. Which side are you going to shade?
I'm going to be shading the left.
Okay.
That seems simple enough.
Yeah, it is actually.
And then it has to be a dotted line too.
Yes.
Okay. So the next one I have is y is less than or equal to 4.
How does that graph?
So it's going to be horizontal this time, goes on the y-axis at 4.
Solid or
And
dashed?
it's going to be solid because it's less than or equal to. And it's going to be below because it's less than.
I think you got the hang of it.
Yeah, it was pretty simple. Okay. Next one I have is graph the system below and write its solution.
Okay.
So I have negative 3x plus y equals 7. And there's a bracket in front of it, like a big bracket, because I have another number that I'm going to put down below. And that's going to be y equals 1/2 x
Bracket
plus
being
2.
like this.
Yeah, or not like that, but yeah, it kind of is like that, but it has like the little V in the middle of it.
Because I've never seen the bracket or parentheses used there. In other words,
Yeah.
this is a system of inequalities. Were these equal signs, or did I get that wrong?
No, those were correct. Yeah, it's supposed to be y equals 1/2 x plus 2.
Okay.
And so it's asking me to graph it and find its solution.
Yeah, okay. Well, we could do this algebraically. If you were going to do it algebraically, would you use substitution or elimination?
It's actually 1/2 x plus 2
Ah,
for y. Yeah.
that makes a big difference. Same question, though. Would you use
Mm-hmm.
substitution or elimination?
I would do elimination.
Okay, when you have one equation that's not in standard format, that's in
Okay.
x plus b format. In other words,
Correct.
this second equation is solved for y completely. Substitution works easier. Here's how I'm going to do it. Whenever I run across y, I'm going to substitute 1/2 x plus 2. And now I have one equation, one unknown. I can solve that pretty easily.
Yeah, I see now.
Okay? So this is the difference between using substitution and using elimination. And the rule of thumb that I use every time is if it's in standard format, use elimination. If it's not, if both are not in standard format and one is totally solved, it doesn't have to be y. If they told us x was equal to something, then I would do the same thing. In other words, as long as I have one equation solved for one variable, I'm using substitution.
Okay.
Now, if we want to solve this by graphing, you can actually solve it by substitution, elimination, or graphing. Graphing is going to be the point where these two lines intersect. So let's plot the easy one first, the one that's in easy format.
Okay, so that's going to be going up to, for starters. And then I'm going to move up 1 and go to the right 2.
Solid line. This is not an inequality, so that's what that line equals. Now, how do I graph the first one?
The first one, would I have to get into standard form?
I would. It's actually in standard form. The form you want it in is slope-intercept.
Yes.
This is called standard form. What you want it in is slope-intercept, where you end up, this was in slope-intercept form, this one right there.
Gotcha, yep.
So how do I get it in slope-intercept form?
Add 3x and it'll be y equals 3x plus 7.
Now graph that.
So I'm going to, for starters, go up to 7, Mark that there. Then go up 3, which will bring me to 10. Then go to the right 1. And that'll be solid as well.
Now, that is our solution. But what you can see right away is that if I don't have grid paper, it's going to be hard.
I have grid paper, so it works.
Solution. I mean, I can read that solution as approximately -3 plus 2 or something, but I would have no confidence in that at all. If I had grid paper and I had a ruler, then I would have confidence. I'd be pretty certain what the solution would be. But without that, I'm going to always solve this algebraically to come up with the solution. I'm never going to depend on the graphical solution. Now, when you get to inequalities, it's a whole different story, and maybe you have a couple of those. You have a couple of inequalities that they want you to solve by graphing, and that's the only way you can solve them.
Give me 1 second, let me look.
Or you'd have two
graphing inequality
instead of 2 equations. What you just gave me was 2 equations.
I have one for you. Now it's 4x plus y is greater than or equal to 1.
Is there a second inequality?
Graphing a system of 2 linear equalities.
Perfect. That's what.
It says that I have to solve this one first, and then it'll let me do that one.
Okay.
Actually, no. Wait, hold up. I got it, I think. Give me 1 second. Now I have it.
Okay.
So y is less than or equal to 2x plus 7.
Okay.
And then it'll be over y is greater than negative 3x minus 7.
So this first one is not the one we want?
Correct.
Okay. So this one, the solution is only going to be graphically knowable, and you'll see why. So graph the inequality number 1.
Okay. So that will be up 7. Then I'm going to bring it up 2, so it'll be 9, and then to the right 1.
Solid line, dotted line?
It will be a solid since it's equal to. And then the bottom one.
Hold on, which side of that are we shading?
Since it's less than, I'll be shading to the right side technically, so the bottom.
Yes, please don't ever say right or left. Always say top or bottom, unless it's that one case where it's X. And the reason why I say that is because I always want you to be looking at the y-axis. And that says y is less than this line. So it's definitely bottom. Now, let's graph this second one in blue. Where do I start?
So I'm going to be down 7. Then I'll go up 3 and to the left 1.
Dotted or solid?
It will be dotted.
And above or below?
It'll be above.
So if we want to shade the area that's in common, then it's this area right here.
Okay.
In other words, that's the solution set. And notice one thing that I cannot do. If I want to describe the solution set to you, I can do it one of 2 ways. I can do it this way here, that's an answer, or this way here, that's an answer. But I can't give you a solution other than graphical or with 2 inequalities. I can't turn this into a single x is greater than or y is less than, like I was able to. In other words, when they were equations, the answer is right there.
Mm-hmm.
Now, there's a couple of other things here. If I said to you, oh, no good. If I said to you, is the point 2, 2 in our solution set?
Say that one more time.
That point right there, 2, 2. Is that in the solution?
Yes.
Yeah, and if you plug it in, you'd see that 2 is less than 11. So it works on that one, and 2 is greater than minus 13. So it works on the second one also. Now, if I gave you this point right there, is that in the solution set?
No, it is not.
Yes, it is. Because
Wait, point at it again?
It's on a solid line. In other words, if that point is on the line, it's in the solution set. Because it's less than or equal.
Okay. But if it was a dotted, no.
Exactly. If I put a point right there, that is not in the solution.
Okay, fair enough.
If I put a point right there, that is in the solution, I think. To be honest, I'm not 100% sure. But that's the way it works. And you can see that there's no easy way. If I'm trying to describe that solution set, that's not easy to do. How do you do such a thing? The only way to do it is by those two inequalities, a system of inequalities.
Okay. So I have another one. So 1 second. Okay, this one is y is greater than or equal to 2x minus 5. And then it's y is less than negative 5x minus 6. So for starters, I'm going to go down 5. Then I'm going to go up 2 and go right 1.
Kind of line?
And it will be a solid line.
Which side?
It's going to be above.
Second line?
Second line is going to go down 6. Then I'm going to go up 5 and to the left 1.
Solid or dotted? I mean, solid or dashed?
This one will be a dashed line.
Oh, there. What the heck? Hold on a second. Pen is
Okay.
acting up. Actually, I think I just had my pad oriented wrong. Which side?
Okay. And it's going to be below it.
So the region is all of that. Out to
Not the little cone in the
out
middle.
to infinity, both vertically and horizontally.
But nothing in the middle of the two.
Well, any point that's in my green area is going to satisfy both of those inequalities.
Okay. But I'm just wondering as far as shading, since I saw that for the first graph it was above it, so it doesn't stay inside of that area.
Look at what that above means. In other words, this area here is above the first graph, but it's not below the blue.
Oh, so it has to be for
It
both
has to
of them.
be covered by both. Now,
Okay.
one way you could do it is use horizontal line. Here, let me use the correct color. I use horizontal lines. That's for the first equation. And then the second equation, I'm going to use vertical lines. And my solution set is only where I have both horizontal and vertical. And that solution set is right in here, only that's a dotted orange line, a dashed orange line.
Okay.
Okay? But yeah, when you get your two arrows, you have to figure out which is covered by both. And there's a number of ways you can do it. You can use two different colors, you can use horizontal and vertical stripes, or you can just use the arrows that I used. That's not quite as clear, but you can figure it out.
Okay.
But this is a situation where a picture is not worth 1,000 words, but it's worth 11 letters. In other words, if I
I
want
see.
to describe this area to you, I can do it with that graph, or I can do it with those two inequalities. There's no other way to do it. There's no nice and simple answer like, x is less than 5 and y is greater than 2. You have to either describe that area with these two inequalities or graphically.
Okay.
As opposed to
So,
two equations, which would be totally different. Best way to describe two equations is with x equals a number and y equals a number.
how come that way?
Well, because you can. In other words, if it's two equations, the only solution is where they cross. If I have two equations and one of them is that line and the other one is that line, that's the solution. That solution I can define by an x and a y coordinate. That's all I need to find the solution set. But if I'm talking inequalities, well then one is that whole area there, and the other is this whole area here, then the solution set cannot be described by much. It's this, right? How do you describe that? You can't really do it other than using the two inequalities that we started with. You can do it that way, or you can do it graphically. You just can't do it with a simple method like you can for two equations.
Okay. I'm pulling up the next one.
Okay.
Okay, so for this one, solve the following system. It is 2x plus y equals 2. Then it's negative 3x plus z equals negative 7. Then it's negative 4y plus 3z equals 22.
And notice I put the variables under one another. In other words, the moment you gave me three variables, I knew there had to be a third equation. Okay.
Since there was something with the z in it.
Well, we're going to use the same strategy we used when we had two equations with two variables. And that is to get rid of one of the variables. Can I get rid of z easily?
To get rid of z easily, multiply it by 3.
Okay. So here's equation 1, 2, 3. We're going to take equation number 2, multiply it by 3, which gives me 9x plus 3z equals minus 21. Cross that one out. Because especially when you have three equations and three unknowns, you end up with equations all over your page. And that's why I number them, and when I'm done with one, I cross it out. Now,
Okay.
what's the next step?
So now that they're both there, I want to, or should I have made it negative?
Well, let's do a subtraction, just so you know you can do it. So I'm going to subtract 3 minus 2. That's going to get rid of
time,
right? In other words, 3z minus 3z is no more z's. But what's 4y minus a minus 9y?
Say that more time, please. Negative 4y minus. It would just be negative 4y minus 9x.
It'd be plus 9x.
Since, how come?
Because it's a negative and a negative.
Okay, I see that.
That's why it's better to always set them up as addition problems. So let's go back and do that. What is that in front of the 9x? So I want to multiply by minus 3, right?
Mm-hmm.
So that's plus 9x minus 3z plus 21. Now, add them together. What do you have?
So that'll give me 9x and 0z.
Well, 9x plus 4y.
Okay, 9x plus 4y.
Equals 43.
Equals 20, or yeah, 41. I mean, 43.
Okay. Now, notice what we have. We've taken our three equations and three unknowns, and we have down to two equations and here's the next one. And whenever you have 3 and 3, you always end up creating 4 and 5. Equation number 4 is the top one. 2x plus y equals 2. Equation number 5 is what I produced down there that only has x's and y's in it. In other words, I don't want any more z's because now I have two equations, two unknowns, and I can solve that. I know I can solve that system of equations. So how do I do it?
So for this one, I'm just going to multiply the top by 4.
Negative 4.
Negative 4.
Negative 8x, negative 4y equals negative 8. Box that one out. Now what?
So now it'd be x plus 0y equals 43 minus 8. So that would be 35.
There you go. Now, once you solve for x, I can now use that one to solve for y. What is y?
So I put the 35 in there.
For x?
And that would be on the original equation, correct?
The easiest one. Yeah.
Okay, so let's do it on the first one.
Yeah, that's by far the easiest one. So you have
So
70
that'll bring
plus
it to
y.
70.
What's y equal?
So I'm going to subtract the 70, and that'll be negative 68 equals y.
Okay. Now that we've solved for x and y, in order to solve for z, I'll go to the next simplest equation, that one right there. So substituting 35 for x gives me minus 105 plus z equals minus 7. Z equals 90.
So plus 105, yeah, 98.
And you always have to do these in this exact order. Some are actually, this is actually, I don't know if it's more complicated or less complicated. It's less complicated in one aspect, but it's more complicated, and it doesn't really show you how to do one if I had all three variables in all three equations. So this was slightly less complicated than that would be. Do you have one like that? Where you have three equations and each equation has all three variables in it? Because there's an extra step that's needed if you have that. And I can't really make one up in my head just because it's hard to do. Here, let's see if I can make one up. See, I can't just put a number down there because it wouldn't necessarily agree with the first one. So I can't make it up. I don't have one to draw upon. But if you don't have one like that, that's okay. Taylor, you still there?
Mr. Cowan, can you hear me?
Yeah, I think I might have lost you there for a moment.
Okay.
I was going to try to make one up, and I realized I can't do it. It's too hard to make one up on my head. Do you have one that has three equations, and each equation has three variables? In other words, an x, a y, and a z on all three?
I'm looking right now. Let me see if this one has one.
I could find one, but if you don't have...
Actually, yes, I do. Yes, I do. Yep. Okay. So it is 2x plus y plus 2z equals negative 2. Then there's negative x plus 2y minus 2z equals negative 5. Then it's 2x plus y plus 4z equals 0.
Now, the secret is I'm going to take two of these equations and eliminate a variable. Then I'm going to take two other equations, other than the first two that I used, and eliminate the same variable. You can't eliminate a different variable. And that's why I wanted to do one like this. So, which variable can we eliminate fairly easily?
I see the two z's.
Yeah, we could just add 1 to 2 right off the get-go, right?
Yes.
And that's going to eliminate z and give us x plus 3y, no z's, equals minus 7. That's equation 4. Now, we need an equation 5 that is just in x and y. So I have to eliminate z in my next step. How can I eliminate z, and which two equations should I use? Don't count 4. In other words, I've already used 1 and 2. So I can now use 1 and 3 or 2 and 3.
Okay, so 1 and 3 or 2 and 3.
Which ones? You tell me. You have to choose one.
Okay, so I'll use equation 1 and equation 3.
Okay. Tell me what you're going to do to equation 1.
And we're trying to eliminate the z's, correct?
Correct.
So for equation 1, I'll multiply it by -2.
Perfect. Okay. That gives us minus 4x minus 2y minus 4z equals 4. And I'm going to combine it with equation 3 because that's perfect. I can just add the two together and the z will go away. And that's what I have to do is, was that equation 3 equals 0? Did I write that down properly?
2x plus y plus 0, correct.
Okay. So that's 0. Now I'm going to add 1 to 3, and this is going to be my equation 5. So I get minus 2x minus y, no z's, equals 4. Now I take 4 and 5 and treat it like a system of two equations. Here's 4. Here's 5. What's the easiest way to solve this one?
For this one, just multiply the top by 2.
Okay. Gives me a 2 there, a 6 there, and a 14 there. Now adding the two together gives me 5y equals 10, y equals 2. It does not matter which variable you solve for first. The key is to pick a variable, eliminate it for equation 4, pick the same variable and try to figure out how to eliminate it for an equation 5. And we did. And once I have equation 4 that's just in x and y, and equation 5 that's just in x and y, I can solve for a variable by using just elimination. So now that I solve for one variable, I got to go back and solve for the second variable from one of these equations that only has x and y in it. In other words, I can't solve for anything if I go back to equation 1. That's got 3 variables in it. So far, I've only solved for y. So let's solve for x. I can use either of those two equations to solve for x, which is the simplest one.
I'd say equation 1.
How about this one? That's got nothing but small numbers, positive signs, and 0 on one side.
Okay, so 2x plus y.
Equation, what I've labeled 3.
Okay.
Okay, so I substitute 2 for y, and I get 2x
Plus 2.
Well, hold on. I apologize. I made a mistake there. I'm substituting it into equation 5, not equation 3. Equation 3 has 3 variables in it. I got to find an equation that only has 2 variables. Actually, equation 4 would be my easiest one. Let's use it. X plus 6, which is 3 times y, equals minus 7. X equals minus 13. So that was pretty easy to solve for x. Now you go back to one of your 3 original equations to solve for z. And
Okay.
I suppose I would use equation 1. That's got lots of small numbers. So x is minus 13, so it's 2 times minus 13. Y is 2 plus 2z equals minus 2. And if you do all that math, you get minus 24. That's plus 26. Z is going to be 13. And that's the way you do most 3 equations and 3 variables. That's actually the easiest way to do it, is when you have all 3 variables and all 3 equations. I have often found that it's really easy to get confused if they give you 3 equations and they leave out a variable out of a couple of them. Like the previous problem you gave me. It did not have all 3 variables in all 3 equations. But the key, nonetheless, is the same. The key is to eliminate one of those variables and then eliminate or use the equation that doesn't have that variable in it. In other words, there's all kinds of easier steps after that, but you've got to get it down to an equation 4 and an equation 5 that only have 2 variables, the same 2 in each. It wouldn't do any good if that was a z. I can't solve it. It's got to be x and y, or y and z, or x and z. It does not matter which variable you eliminate first.
Okay.
Might have time for a short one.
Okay, I got one now.
Okay.
I'm pulling it up. So it's back to solving a system of linear equations.
Okay.
So it's x plus 2y equals -1. And then y. So
I didn't hear the rest of that. Y is what?
y equals 3x plus 3.
You're going to use elimination or substitution?
I'll just do
Always the first thing you have to answer, always. Elimination only works really well if they're both in standard format, and these are not. In other words, I would have to manipulate that equation to get it into standard format. I'd have to move the 3x onto the other side, which I could do easy enough, but notice how easy it is to do by substitution. I go into equation 1, that's x. Well, they're telling me what y is. Y is 3x plus 3 equals -1. Now it's a piece of cake. That
so
becomes
6x plus 6 equals -1.
Which is 7x equals -7, x equal -1. And then go into that equation, put x equal -1, and you get an answer of y equals 0. Yep. That's your 2 solutions.
So how would I plot that?
Well, if you were to graph each line, the second one graphs relatively easy, slope of 3. And the first one graphs, I'm going to have to put that in standard format or slope-intercept format to graph it. So it's going to be at -1/2, and it's going to be a slope of 1/2. So,
Up 1, then to the right 2.
It's going to be a slope of -1/2, I'm sorry. So this is the graph of equation 1. This is the graph of equation 2. And their intersection point should be at x equal -1, y equals 0. And it is.
Okay. I got it.
So only use elimination when you're looking at 2 equations that are in standard format. That is standard format. This is slope-intercept format. If they're not in the same format, then elimination isn't going to be the easiest way to go. You could still use it, but you got to put one of them into slope standard format if you want to use slope-intercept form, or if you want to use elimination.
Okay.
Okay?
That's about it that we've got for now.
Okay, Taylor.
Thank you for the help.
You're welcome. Talk to you later.
Sounds good. Have a good night. Bye-bye.
How did you guys know I was done? Don't tell me you can time. How did you doggies know I was done?